simple. This is just a placeholder. It's not really the talk. I'll have a link to the talk somewhere in the description of this video. You have to watch the talk on D12 Pinapto. And at the end of this talk, you need to understand the following topic. Talks suggested a deeper look into Quicksort. Presumably you are familiar with Quicksort. Quicksort looks at an array full of keys and pick one of them as a pivot and perform a partition after which all the elements to the left side after which the partition, the somehow left side of the array is full of elements which are smaller than the pivot x, smaller or equal than the pivot x, then x itself, and then keys on the right side which are all larger than x. That's in Quicksort. Once it's done with the very first partition, will call itself recursively on the right side and on the left side. These two calls to the recursion. And you need to understand this part. You need to understand what are the worst case running time. For example, when the array is already sorted and the pivot will be picked as the smallest element of the array, then the running time will be quadratic. On the other hand, the best case running time is if you're picking the pivot to be just the median, very unlikely, but possibly. And in this case, the running time will be n log 2 of n. Check the lecture. That's just in this case, every side of the sub-arrays would be of size n half. Since usually we don't know what is a good pivot and what is not, instead we pick either a key from the array, or even better, we pick a few keys, say 5 random keys from the array itself, 5 random indices from the index itself, not values, but they are keys from the array, and we are assigning the pivot to be the median of these 5 keys. And you do have to analyze what's the probability that the pivot that we pick using this method is not very good or not very bad. Very good, or a good enough pivot will just have to be not in the very small 10% of the elements and not in the very top largest 10% of the keys. As long as this pivot is in the middle 80%, not very small, not very large, then the running time will still be n log n. And there is no guarantee that it will always happen, but if you follow the analysis, which you will do before the midterm, if you follow the analysis, you'll see that the probability of picking a good pivot is actually 98%, which is very high for all purposes, and there is no much damage of calling the partitions, even if the remaining 2%, even in the remaining 2% that are not too harmful. However, do understand the analysis of what the probability of picking a good pivot in this video. Finally, study from this video what is a method of the randomized median selection, or the randomized k largest element in the array. I want to pick an element which is larger than, say, half of the keys in the array. Or in general, I want to pick, somebody gave me a value k, and I want to pick an element which is larger than k other keys in the array. K might be just n half in the case of a median, but it might change as the algorithm progressed. And do understand why, as long as our medians, this algorithm runs in expected linear time. It's expected because its worst case is also n squared, just as Quicksort. However, its expected time, as opposed to Quicksort, is only linear. Why does this miracle happen? Well, watch the video, but essentially there is great amount of similarity between quicksort and randomized median selection. Again, quicksort and randomized median selection are very similar if you look at their code, but the big difference is that quicksort, after the partition, called itself both on the left side and on the right side of the array. Randomized median selection will call itself on the left side of the array or on the right side of the array, never on both sides of the array recursively. And actually, there is also a chance that the pivot itself is the median, which we'll know after the partition, and then the algorithm will stop. That's quite unlikely. It might happen, but even if it doesn't happen, we never need to double the work of calling ourselves both on the left side and the right side. It's either on the left or on the right, and that's how randomized median selection can run in linear time while quicksort runs in expected and log n time. But go and watch the full lecture to fully understand it. Thanks, bye.